بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. My name is Ali Janabi and my colleagues are Ahmed Saeed and Taqil Ajmi. We are going to give you a demonstration of our project for COE 444 course. Our project is an implementation of a smart office system and Cisco Packet Tracer software. So basically our project consists of 3 networks: an external network, an ISP backbone network, and the smart office network. The ISP backbone network uses 2 protocols, EIGRP for internal PGP and BGP for external PGP. The smart office network uses OSPF protocol. The ISP backbone network is connected to 2 routers, ISP2 and ISP. The external and smart office network can communicate through these routers, and these routers cannot see the internal IP addresses for the networks because we have used NATing at external 1 and router 0 routers. We can see the NATing configuration at external router from here. You can see that we have used an access list that has the private addresses for this network, and a NAT pool because we have used dynamic NATing. And from router 0, we can see that we have used port address translation because we don't have that many IP addresses or that many external IP addresses, and we have used static NAT for the servers inside the smart office network. For the web server specifically, we have used TCP with ports 80 and 443 NAT. Because if someone wants to access a website, he can use HTTP and HTTPS. Now let's move on to the smart office network. On the right side, we have 5 departments: the manager, the IT, the marketing, the HR, and the customer service. Each department has its own VLAN. We have also a separate VLAN for voice over IP. And on the left side, we have 4 systems: the parking system, the fire alarm system, the appliances control system, and a security system. Next to that, we have the routers inside the network, the IT, the DHCP, the web server, the email server, and the DNS server. Now let's move to the physical view. So if you want to use voice over IP, for example, if the manager wants to communicate with phone 10 or the employee at phone 10, he can dial his number. We can see that the 2 phones are connected and now they can communicate. Now let's go outside the network. So if someone wants to use some services from the inside, and for example he wants to open our company website, he can do that using the domain. And also he can use HTTPS. Moreover, we can connect to the IT registration server, use our credentials, and also we can see the conditions. For devices that use MQTT protocol, we can also connect to the broker, subscribe to topics, and also publish and receive messages. And further details will be explained by my colleagues. And for the email, if an employee wants to communicate with another employee inside the company, he can configure his email at his smartphone, and he can send an email to the employee. If he wants to say good morning, for example. Can see that send is success. And if we go to PC1, can see good morning. And the rest will be explained by my colleague Ahmed.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ahmed Saeed. I will continue with the system we configure in Smart Office. I will explain it in the physical mode. As we can see, we have an external network here with the ISP, and here the office. First, I will explain the smart parking system. As the employee come to the office, his car had RFID card embedded inside it, so it will be easy for the employee to enter the gate, and the gate reader will read the car RFID to open the door. When the employee come to the parking, they can see the available parking by this screen I represented here. When I try to connect with the ISP, as we can see here, that parking 3 is available. When he park in the parking 3, the state of the parking will change, as we can see here. Also, the system can be used to see from inside the company as a PC10 connected as a client, MQTT client. We close the news. Yes, here, as we can see, it's connected to the broker, which is inside the server here, the IoT server, as IoT registration server and MQTT broker. When we connect, we subscribe for multiple things like light, coffee, AC, parking, fire, and door. And we will try to see the parking status, like type in parking, payload parking, and publish. As we can see, all the parking, the messages parking and payload parking, the ISP will send back the status of the parking. All the parking is not available. This can be also accessed from outside the office, but we have some issue with the message. Doesn't read it correctly. Let me close this one. as the IP, external IP for the broker is 4.4.4.3 with admin credential. When we type parking, it should receive the status that all the parking is available, not available, as we can see here. All the parking not available. Also, we implement a fire alarm system that connected with database, Firebase database, but we connect the server outside the Packet Tracer, as we can see here. This is the connection, which is we get the URL from the Firebase, and we try to connect it with the my PC IP. Because the alarm will send the packet to the server here, and then the server will send it to the database, embed it with the time and the message. As we make the fire close to the fire monitor here, the alarm will be on and the sprinkler will be on with the window. And we can see that it is publishing that there is a fire, because we are connected as MQTT also. There is a message, fire in office. Also in the database, as you can see here, there is a fire in office with the same time. The rest of the system with my colleague Taqi.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Taqi Ajmi and I'm going to continue explaining the rest of the systems. We have implement appliance control systems. The light and coffee maker and the door can be controlled using MQTT. For example, when we go to PC10, MQTT client, we go to topic, we write here live, payload on, publish, the light will be turned on. We write off, publish, the light will be turned off. But the coffee maker, we write here coffee, and on, publish, the coffee will be turned on, the coffee maker will be turned on, and if we wanted to turn it off, we just write off here, and we click publish. Also, we can control this door by writing here door, and open, publish, the door will be opened. We can also close it by writing close. Also, the door is connected to the register server, so we can control it by using MQTT and register server. We have an RFID card here. If we put the RFID card on the RFID card reader, the door will be unlocked. Also, we have implemented AC that connected with a thermostat. If the temperature is greater than 25, the AC will be turned on. If it is less than 25, the AC will be turned off. Moreover, we have implemented a security system here, which consists of motion detection and a camera. If the motion detection detects a motion, the camera will start recording. Also, we have implement an entertainment system, which consists of a media player and a speaker. We can control the media player. For example, when you go to PC10, and IoT monitor. Okay, we go to a portable music player and we click on this button. The music will start. Okay, that's it. Thank you very much.